Welcome to Google Cloud's digital conference. Let's talk AI. Today we are going to talk about principles of big data in the cloud. I'm Sudhir Hasbe, Director of Product Management for Data Analytics Services at Google Cloud. And today I'm joined by
Bob Bradley, Data Solutions Manager at Geotab.
And we also have Googlers on standby to answer your questions live. So please click on the icon on the left and ask away. You all must have used Google search. Behind the Google search, there's a tremendous amount of infrastructure, the machine learning and analytics foundation that makes those wonderful, simple experiences possible. Over 18 years, we have been building secure and trusted infrastructure for processing massive volumes of data. We are the leaders in field of machine learning and AI to better organize the world's information. Other than search, we have total 8 products that are used by more than billion users. And all of these products are leveraging the same infrastructure at scale to go ahead and give those experiences. For example, today morning I was coming from JFK Airport to New York office of Google, and I wanted to know what were the directions, what was the traffic like, how much time it's going to take, and Google Maps was able to show all that information to me. Those magical experiences are possible because of the investments in the infrastructure that we have done over 18 years. Big data is in our DNA. That's what we do. That's what we are investing in over time. The other thing is there will be 163 zettabytes of data by 2025 according to IDC. And that means data in all the organizations, and every organization is just going to keep growing. And AI is the new ground for gaining competitive advantage and creating business value. Organizations that are using AI already are seeing 2x more data-driven decisions, 5x more decisions than others, their peers, and 3x faster execution on those decisions that they're making. If your company is not good at analytics and data, it's not going to be ready for AI. 80% of the times, data scientists are spending on cleansing data, preparing data, and making sure the data is ready for AI. And that's why it's really important to focus on data collection, processing, analysis, that side of the spectrum. Less than 1% of unstructured data and less than 50% of structured data is actually used in making decisions today. And we want to change that at Google. We have 4 key principles that we are using to go ahead and build our solutions in Google Cloud. So one is we want you to focus on analytics, not on infrastructure. We want to take care of all the infrastructure side of things for you. Second, developing end-to-end comprehensive services and solutions that give you all the capabilities you need. We want to provide you solutions that can handle the whole end-to-end machine learning life cycle. And then being innovative and open is really critical and important for us. And so let's talk about the first one, serverless. We have most services that Google has are serverless. What that means is you can now focus on analysis instead of doing monitoring, performance tuning, utilization improvement, or basically resource provisioning or resource planning, all of that. All that goes away. And we take care of all of those things for you, so you can just bring your data in and start analyzing. The next key thing is end-to-end complete solution. So you want, it's not just important to have an analysis service or something to analyze, but you also want to focus on ingestion. So we have services that allow you to ingest data at scale. Must be, even if the data is events that you're collecting in real time or massive amounts of data that you want to move to cloud, we have service for that. We have solution for real-time streaming, analytics, processing of the data in batch or in real time. Then we have products like BigQuery, where you can go ahead and analyze this data at scale. And then for advanced analytics, you can use ML Engine, you can use Data Studio, you can use TensorFlow for all of this. And then you can bring all of these services together using Cloud Composer, which allows you to create workflows that are spanning across different solutions or services that we have. The next is, let's talk about the machine learning lifecycle. The machine learning lifecycle, if you look at it, starts with ingestion, exploration, preparation, and pre-processing. This is the whole part around data processing that you need to do to make your data ready so that you can leverage it in machine learning. And on machine learning side, then you want to train your models, you want to hyper-tune them, you want to test them, and then you want to predict both in online as well as in batch mode. So all of this end-to-end lifecycle can be managed through Google Cloud. The most important thing, as I was saying, innovation and openness is super important to us. Over the last 15 years, we have innovated in a lot of different areas around big data, and we have made those innovations available to the industry. So if you think about everything, the papers that we have published from GFS, MapReduce, Dremel, to all the different things up till TensorFlow, all of these are available for the industry. And then we have invested in products that come out of these, but also we push back a lot of changes in the open source community for the open source side of the products. The next thing is we are seeing momentum across the globe for our data analytics capabilities. We have customers in almost every vertical: financial services, retail, gaming, media, entertainment, across the board, across all industry verticals. Our customers are bringing in like less than 10 terabytes, and we have customers that are putting in like 100 plus petabytes into the data warehousing solution that we have. So a spectrum of different size of customers. And then we also have cloud native companies as well as traditional enterprises who value security, who value encryption, all of those things a lot. So we have spectrum of customers using the products. So if you think about data analytics solutions for enterprises, we have 4 key areas that we focus on: modernizing your data warehouse, analyzing streaming data, run powerful open source solutions, and visualizing and activating your data. So let's first focus on modernizing your data warehouse. BigQuery. BigQuery is our cloud scale data warehouse. It can handle petabyte scale data sets, and it can run queries on them within seconds to minutes. It supports standard SQL. So all the investment that you have within your data analytics team with SQL, it's all transferable. It's fully managed and serverless, so you just have to bring your data, and then you can actually start free because we have free tier, and you can just bring the data in and start writing queries, start analyzing the data you have. And most importantly, we also enable you to go ahead and do direct streaming of data into BigQuery. I was talking to King last week, and they publish like 50 billion events every day into BigQuery and analyze that as the events are coming in. So it's a massive scale that you can leverage coming from BigQuery. One of the other things we noticed is, if you think about machine learning, there are 2 challenges for machine learning in the industry. One is skill set gap. So what's happening is there are not enough PhD data scientists in the industry to go ahead and do machine learning. And the second is, you always have to move data from where it is. In our case, a lot of customers bring data into BigQuery, and now if they have to create a machine learning model, you have to take all that data, move it into a machine learning engine or some other machine learning capability. You realize something is not right. You have to go back, you actually change it again, and keep moving all of that again and again. We wanted to solve that. And BigQuery ML is basically the solution for that. BigQuery ML is basically simplifying machine learning by just making it available through SQL within our BigQuery environment. It's just 2 lines of code. You basically say create model name, and give a select statement that actually has input for it. And then for prediction, you just say select ml.predict, and you can start predicting values. We support linear regression and logistical regression today, and then we are investing more and more into that space. The other key innovation that we just announced recently is this GIS, so geospatial data and capabilities of geospatial analytics in BigQuery. What can you do with it? For example, if you're a retailer, you have logistical distribution centers, and you want to know all the packages that you're shipping in the 2-mile radius and where are those, and you want to analyze that, and you say which is the best shipping mechanism for doing that, you can do that. Or if you're in retail and you want to know, you're a retail analyst and you want to know in 1 mile, 3 mile, 5 mile ring studies of potential retail store locations to target your customer demographics, what would it look like? All of these kind of scenarios are now possible using BigQuery. And I would like to invite Bob to share with us what they're doing at Geotab with BigQuery ML and GIS.
Thanks, Sudhir. So before I talk a little bit about how we use BQGIS and BQML, I'd like to introduce what Geotab does. So Geotab is a global leader in telematics. We have over 1.2 million connected vehicles worldwide, and they're all using our IoT device that we manufacture. We provide an open platform for our customers to manage their fleet, and we pump over 3 billion records from these vehicles every single day into Google BigQuery. What's special about these 3 billion records is that they're actually curve logged by a patented algorithm that we developed. And what that means is that we use BigQuery to expand these 3 billion records and interpolate them out into about 40 billion records every day. And beyond the vehicles, our infrastructure also reports into Google BigQuery. So Geotab really truly does run on big data. Now our data, we like to think, is the richest telematics data set in the world. And the reason for that is that we're more than just dots on a map, although we have an awful lot of them. As you can see there, that's 1 day of Geotab data. But we also collect engine data from the vehicles, weather data from the vehicles, traffic flow, driver behavior. So we have an incredibly rich data set of information from these vehicles that you might not expect. And one of the side effects of getting all of this wonderful data is that we can start to make some decisions and provide information to city planners to make better decisions in smart cities. Growth in cities is definitely causing a problem. There's traffic problems. I saw that on the way here from the airport into the New York office. And we can't just pave more roads, so we need to make data-driven decisions. Our 1.2 million vehicles driving around every single day provide us information about traffic, information about weather, information about precipitation. And then we can use this information as a city planner to make decisions within our municipality. Now, before I talk about BQGIS, I also wanted to mention that we've been doing GIS in BigQuery for years. And we actually are using UDF functions in JavaScript, inline functions, to do some really, really cool things. And what you see on the map here on the right-hand side is a hyper-local weather map of the city of San Francisco. And the way we pulled this off was to actually use geohashes and JavaScript to bucket our data into small pieces of Earth. So this is a 150 meter by 150 meter, 500 foot by 500 foot box on the Earth, and we can tell exactly at any point in time what the hyper-local temperature is in that area, all within Google BigQuery. Now, what BigQuery GIS does is it expands our capabilities and accelerates our smart city development. Because now what we can do is we can take a shapefile, and every single smart city has a shapefile, and we can combine that using ST operators and get our data across any arbitrary shape. And so what we're looking at here is the same exact map that we did before, but instead of breaking it down by geohash or S2 cell, we can use the native shapefiles that the city is interested in. So in this case, we're looking at temperatures in different neighborhoods of San Francisco. And you can see by the query there that it's as simple as selecting the data out in BigQuery and then joining it with a shapefile that we've also uploaded into BigQuery. So again, all the data stays in BigQuery. And this new process allows us to build some really, really cool applications on top of BigQuery. So you may have seen driving around the types of tubes that are there on the left-hand side to do traffic studies. And the typical process might be that you're concerned about what's happening maybe in front of your child's school. People are driving too quickly. And you call up the city, you make a 311 call, and you report an issue. And they'll do a study. They'll roll out these tubes, and they'll put them on the ground and do a study for 2 weeks and collect the data. And what we can do with BQGIS now is we can actually draw virtual lines on a Google map, and we can use an ST-intersects function to figure out when our vehicles, using lead and lag in BigQuery, drawing lines, when those lines intersect with the fake line, the fake tube that's been drawn on the ground. So it's really, really neat, and we can get insights in seconds, not weeks. So you can imagine a situation where maybe the Google Assistant is handling these calls, and we're automatically delivering these types of insights to a city planner. And that's really, really cool, and that shows us what's happening at a point in time. But we were also introduced to BQML, and we combined BigQuery ML and BigQuery GIS to see if we could make a tool that allows city planners to be predictive about changes in their city. And we tried to predict hazardous driving areas, and I'll show you a demo. So what I'm going to show you is actually a demo where a city planner can see hazardous driving areas in their municipality. In this case, we're looking at Chicago. And they can actually predict what will happen in that city if the weather changes. So if it rains, or if it snows, or if it gets cold, or visibility drops. And so the way we did this was combining BQML with BQGIS. And the way we detect hazardous driving is by looking at driving behavior of 1.2 million vehicles at scale. Are vehicles hitting their brakes too hard? Are they swerving? Are they accelerating more than they should? And these can be indicative of blind rises or missing signs or bad road conditions. And so before we built this model, we had to see, is there a difference in Chicago in the winter and the summer in terms of hazardous driving? And so we put together two maps, and we used the ST functions from BigQuery GIS to snap to grid, and we looked at areas. And we said, in a given area, how hazardous is that area on a summer day versus a winter day? And the more orange and yellow the point is, the more hazardous it is. And so what's important to see here is that the colors are very different. And so there is a measurable difference in winter and summer. An interesting fact here is that the highways themselves haven't changed much. So it seems like you're much more likely to have an issue on the way home from the highway than you are traveling on the highway. But this is good news. There's a big difference, and it's a simple query for us to check this. We didn't have to pull the data out of BigQuery, and now we can push ahead with our model. And so, what do we need to do? So to look at Chicago, we can do the same thing we've done before. We can use an ST function, ST contains, to only select those vehicles that we have driving around in Chicago, and we can give a city planner a quick and easy way to look at what's happening in their area today. But what if they want to look at it tomorrow with snow, or tomorrow with snow and reduced visibility? How would they do that? So lucky for us, BigQuery has a way to do this now in BQML. And so if we're going to train a model and we're going to look at weather as a factor, we also need weather data. And another good thing about doing stuff in BigQuery is that there's an open data set of NOAA weather. And so we use that. Again, just joining, not bringing data outside. And so there's a few things going on here, and I'll explain them. So we are creating a model right within BigQuery. So our data scientist isn't leaving the browser tab. And if you look at the bottom half of this query, you can see it's a pretty simple query. Now in reality, there were 300 plus features, but it pretty much looked like this, just a little bit bigger. And what you'll notice is that we're not adjusting any of these columns. We're just pulling them out of our data set. So we're not normalizing them. BigQuery is doing that for us. We're not taking categorical variables and one-hot encoding them. BigQuery is doing that for us. And so we're just selecting the data that we want to train on. And we had 600,000 pieces of data. And we're also not setting a train test split. BigQuery is doing that for us as well. And above that, we're just telling BigQuery that we'd like to create a model. And all we really need to specify here is the label and the model type. In this case, we're setting the minimum relative progress, but we don't have to tune any parameters here. BigQuery will do that for us. And as it runs, it's going to create a table for us showing the results at every single iteration. And so we can look at the loss and we can check for overfitting just from the table that BigQuery creates. And so that's great. We created a model, and it took about 15 minutes to create a model over 600,000 records and 300 fields. But is the model any good? So how can we evaluate this model? Well, again, there's a theme here. We stayed within the browser, we opened a new tab, and we used ML Evaluate. And we can check the accuracy of our model. So as I said, we already checked for overfitting, but in this case, we can pull out other statistics. So for us, we looked at mean squared error, R2 score, and explained variance, and we looked at our model. And if it needed some work, we would go back to the other tab and we would retrain our model. No shuffling data around, very, very quick iterations, grab a cup of coffee and evaluate again. And so good news, the model worked out and we were able to do some predictions. And so how do we predict? Well, again, no surprise here, we can use an ML predict function. So this is fantastic because for us, this is no different than any other query. So we can take a smart city application that we were already working on that would show a city planner where the hazardous areas are in their city, and we can add a predictive component to it. And from a developer's perspective, it's still just a SQL query that they're issuing to the backend. So you can see here in a few lines of code, I can now predict the hazardous areas from the weather. I give it the same type of data that I did on the train and test, and I will get back my predicted severity score. And so let's take a look at a demo of what this would look like in action. So what you're seeing here on the left-hand side of the map is the city of Chicago today. These are the hazardous areas as they are today. And this is already really, really useful information. I can zoom in and look around and identify problem areas. But what if I want to plan for a few months from now when Chicago is going to get much, much colder, visibility might be reduced, it's going to snow, and maybe it's the holiday season and we are going to increase traffic a little bit. What would that look like? And so we can click and run, and we're doing our ML.predict now. And we can see that there's actually some pretty big differences here, especially in this uptown area. So the map looks very different. On the left, still the current situation, and on the right, the predicted. And I'm going to zoom in on an area here that I've already found before here doing this, and it's right in front of a school. So today, there is no issue in front of the school, but with snow and temperature reduction and visibility issues, there seems to be an issue that crops up. So let's take the Pegman and explore a little bit at what's going on this street here. So I've dropped our Pegman on the street, and there's the school down on the left-hand side of the road. And as I drive a little closer to the school, one thing stands out to me is that I don't see any signs about this school. In fact, the only sign that I see is once I get to the school, I see that there's a crossing up ahead. And if I pan to the left and pan to the right, I can see that there's definitely an alleyway here. And if the kids at this school are anything like my kids, they probably don't follow the rules too often, and they're crossing the road here because that's the shortest distance to the school. And if I zoom in even more on the school, I can see that this is actually where the bike rack is. So when the weather gets colder and school opens again and it's not summer and kids are coming to school and they're not obeying the crosswalk sign, there's actually an issue here potentially. Maybe a sign could be added, or a crosswalk could be added, or a stop sign could be added at that intersection to help reduce the chances of a child cutting across the road and cutting off a vehicle. And so this is the type of thing that City Planner can do now with this type of predictive analysis. For all of this to happen, there's a lot of Google services at play. So it's great that BQML and BQGIS happen right within the browser, but the way the data gets there is actually using a bunch of Google services as well. So we're ingesting through custom gateways that we have. Many of those are hosted on Google Cloud Platform. We leverage your streaming engines. We leverage Kubernetes. We use BigQuery throughout the company, Data Lab to run analysis on top of that, and many, many pipelines to clean and normalize the data and extract value out of our data, all running on the Google Cloud Platform. So touching a lot of services, but at the end, our data scientists can iterate over it. They don't need to bring the data out. They don't need to transfer it back and forth, and they can make some really, really cool models right within the browser.
Thanks, Bob. Thanks a lot.
Thanks.
That was a great example of how you can use GIS as well as machine learning capabilities together. Not just this one, there are a lot of other customers who are using these capabilities. Hearst newspaper using it to predict churn of customers. News UK using it for subscription predictions. 20th Century Fox using it for audience conversion and improving the return on investment and all. So a lot of different examples of how it's being used. With that, I want to switch gears now to the second scenario, which was analyzing streaming data. And as streaming is becoming more and more important, we have ability to go ahead and collect events at really large scale. Earlier, I spoke about King, who is they're collecting like 50 billion events a day. But the biggest thing that they mentioned was when they launch a new game, you just don't know how many events are going to come, how many people are going to use it, what was the spike going to look like. And what PubSub allows you to do is dynamically go ahead and collect events and increase the capacity that you need on the Google Cloud side. So you don't have to worry about provisioning, you don't have to worry about anything from an infrastructure perspective. In addition to that, using transformation through data flow allows you to go ahead and automatically scale up and down as these events are coming. And then you can publish those events into BigQuery to analyze at scale, as well as go ahead and use ML Engine to create custom predictive models on top of it. A lot of customers are using the whole streaming capability. Traveloka uses it for all clickstream analysis. Qubit uses it for point of sale transaction collection and making sure the inventory is in the right state all the time. Nintendo for the best Pokeball collectors, as well as Nest for the IoT devices and IoT events. So you see spectrum of scenarios that are being done by customers in that space. The next one is the powerful open source solutions. Data lake is a very common pattern that we have in the industry. Ability to collect structured as well as unstructured data at scale. You can bring all of that in Google Cloud Platform on the cloud storage side. You can leverage BigQuery or Dataproc for analyzing that data, and you can also go ahead and do large-scale processing of it. The other big thing is once the data is available in GCP, you can then use all of our AI capabilities with Cloud ML Engine or with AutoML, any one of our technologies, and go ahead and get value out of that data that you're already publishing. And one of the most important things that we have is Cloud Composer. which basically allows you to create orchestrations that can flow from on-premises systems to Google Cloud and to the machine learning side of the house. So create a single orchestration that can span across all of these different assets that you have. So that's a good example of how customers are creating hybrid scenarios, multi-cloud scenarios. Switching gears to the last one, visualizing and activating your data. One of the most important things for organizations is, once you have collected all this data, how do you make it available to everybody in the organization? Self-service BI is really important. The next is also, it's not just about self-service, but also collaborative capabilities. Ability to go ahead and share what you're seeing, the insights that you're generating is super important within organizations. So with Data Studio, what you're able to go ahead and do is create these amazing visualizations on top of your data. The data can be in BigQuery, it can be in any one of our other data stores. And then from there, you can actually collaborate, share it with people within the organization. One of the key capabilities that Data Studio has is it has a set of pre-built reports that you can go ahead and take, just customize them and start using them. So that's one key capability. The other thing is, earlier I mentioned 80% of the time data scientists are spending in wrangling or cleansing of data, cleaning up the data. Cloud Data Prep, it's our partnership with Trifacta, which allows us to provide the wrangling capability. It's basically helping data scientists to clean the data visually, profile it, and then make sure it's ready for AI and ML capabilities on top of it. The next thing is, yes, partner ecosystem is super important for us. It's important for us to go ahead and leverage and make sure your investment in different tools and skill sets that you have built are continued to be used. For example, the GCP platform actually works really well with all the existing partners in data ingestion space, Fivetran, Stitch, name it. Like if you are invested in data integration partners like Informatica, Talent, all of these, Pentaho, all of these work really well with us, as well as data visualization partners like Looker, like Tableau, like Qlik, like every one of them work really well with the platform. So having said that, the final thing I want to close today with is Google is identified as the leader in Insights platform as a service by Forrester, and so basically Forrester, according to Forrester, they mentioned like their evaluation identified one vendor as a leader based on strengths of its PaaS strategy, advanced tools for batch and real-time solutions, and machine learning and AI offering. So the whole spectrum of thing that we have, that's why we are identified as a leader in this space. And finally, there's a lot more information in this space that's available. Please visit the Big Data Solutions page and you can get all this information. Thank you for joining us today. Please stay tuned for the next session, and we hope you enjoy the conference.